All right, what we're looking for here now is graphing linear equations. All right, and the key here is you only need 2 points to graph a linear relation, but we're going to put more than 2 points on our graphs. All right, because in a linear equation, all you're given is the slope and the y-intercept. You should be able to look at them. Again, say for A here, 2/3, that's our m value. 2 here would be our y-intercept. All right, so the first step in graphing a linear equation is to graph the y-intercept. And so in this case, I see that my y-intercept is 2, and so I'm going to graph it. There we go. 1 point down. Now, the 2 on the top of our slope, that is our rise, which the 3 means our run. And because the rise is 2, that means we're going to have to go up 2, and then the run is 3, and it's positive, we're going to go right 3. All right, so the slope, I've said this a bunch of times, I keep saying it, the slope is the pattern of the line. All right, so from the y-intercept, I go up 2, right 3. There's another point. I could even add more because the pattern of the line is consistent. So up 2, right 3. And that's the pattern from left to right. But if I go right to left, I could go, let's see here, left 3, down 2, left 3, down 2, left 3, down 2, and left 3, down 2. And I can then draw in a line. Now, you should be able to do a better job than that. I don't have a ruler here. All right, on to B. Again, here's our y-intercept. That's the first thing that we want to graph is a 5. So that is where it hits the y-axis. So 1, 2, 3, 4, 5. There's our first point. Again, the slope is going to tell us where to find the other points because it is the pattern of the line. Our rise here is -4. Our run is 3. So that means the rise is -4, down 4, but right 3 is the pattern of the line. So down 1, 2, 3, 4, right 3. There we go. Again, down 4. 1, 2, 3, 4, right 3. And there we go. That's there's our line. I'm gonna try my best here. There we go. All right, let's try a couple more of those different scenarios. I have y equals 4x minus 3. All right, so again, there's my y-intercept. It's at -3 this time, so I'm going to go down 3 on the y-axis. And there's my dot. Now, see the slope is only 4. There's not a rise and a run. There's only the run. You can turn any whole number into a fraction by simply dividing it by 1 because that will not change the value of the slope. 4 divided by 1 is still 4. But now we have a rise, which is 4, and a run of 1. So that is telling me that I need to go up 4 and right 1. So again, we start from our y-intercept. We go 1, 2, 3, 4 up, right 1. 1, 2, 3, 4 up, right 1. And here we go. And I'm going to draw, well, there's my line. Sad attempt, but you get the idea. All right, D, y equals -5x plus 3. Again, I'm going to change this slope to a fraction by just taking -5 and dividing by 1. All right, but that doesn't change the fact that I'm still going to plot my y-intercept here first, which is 3. There we go. That's where it hits the y-axis. Now the slope is telling me I have a run of -5, or a rise of -5, so it's down 5, right 1. So I go 1, 2, 3, 4, 5 down, right 1. 1, 2, 3, 4. I can't get 5 in, so it looks like this is the extent of my line drawing here. See if I can actually draw a line. There we go. That's better. And there we go. There's our equation of our line graphed. All right. Moving on to our next one, E. So let's see here. Again, we have our slope. Our y-intercept is 4. That's the first thing we plot, +4. So again, 1, 2, 3, 4 up on the y-axis. So there's our starting point. All right, and our slope. See how we have a negative sign here? That means the negative sign can either be on the 5 or it can be on the 2. Same thing. All right, So let's see the first one here. Down 5, right 2. So I go 1, 2, 3. Whoops. 1, 2, 3, 4, 5, right 2. There we go. 1, 2, 3, 4, 5, right 2. And here's what I want to show you. Say we use this slope here. What this slope would say is the pattern of the line is up 5, left 2. Well, that's more of our right to left pattern, which it works, because if you watch here, I go left 2, up 5, left 2, up 5. So the patterns can work right to left or right or left to right. But here we go. I'm going to draw my line. And there we go. There's the equation of our line graph. Now I'm going to skip F here, but I am going to move on to my next question, which is graphing linear equations. All right, so here we go. We have somebody has a candy making business, and here's the graph. Use the rate of change to find the amount of candies produced after 10 days. Because as you can see in our graph, 10 days is blank, right? So what we want to do is extend this graph. See, here's our 10 here, but we got no information on that green dotted line. All right, so here's what I'm going to do. Again, I'm going to use my slope here to figure out where or how much candies are produced after 10 days. Now you see that after 0 days makes sense that there is no candies. But after 2 days, we go up, there's 300 candies. So what I'm going to do is, see the slope here, I'm going to go right 2, up 3 on this graph because it's all the same scale. So from this point, I go right 2 and up 1, 2, 3. Just again, the slope following the pattern of the line. Right 2, up 3. All right, still not to my green line yet. Right 2, up 3. There we go. And then right 2, up 1, 2, 3. And lo and behold, now I've hit my green line. And if I just go across here, I can see that how many candies would be right here at this spot, which is 1,500. So again, the key here is I'm following the pattern of what has happened, the slope of the line, to find out how many candies are produced after 10 days.